This is a video on finding the equation of the tangent line. The question states, find the equation of the tangent line to f of x equals x squared minus 7x at the point 1, negative 6. So to find the equation of a line, we need a point, which we have, 1, negative 6, and a slope. And the slope of the tangent line is the derivative. So first let's find the derivative using the derivative formula. And that's, remember, f prime of x is equal to limit as x approaches 0 of f of x plus delta x minus f of x all over delta x. So I plug in. Notice x is equal to 1 here because we're at the point 1, 6, and there's the x coordinate. So that 1 goes in for all my x's. So what I end up getting is the limit as delta x approaches 0 of 1 plus delta x squared, because I'm plugging in 1 for x, 1 plus delta x, into this x. So I get 1 plus delta x squared minus 7, and then I plug in x plus delta x, which is 1 plus delta x. And then minus f of x is 1, so that's minus 1 squared minus 7 times 1, all over delta x. So now let's simplify. I'm going to FOIL the 1 plus delta x out. I'm going to multiply the negative 7 through, and I'm going to subtract 1 minus 7, which is the same as adding 6. So FOILing, I got 1 plus 2 delta x plus delta x squared. Multiplying the negative 7 through, I get negative 7 minus 7 delta x, and then minus 1 plus 7 is plus 6. So now let's simplify. Notice we have 1 minus 7 plus 6. 1 minus 7 is negative 6, plus 6 is 0. So those terms go away. Also, 2 delta x minus 7 delta x is negative 5 delta x. So what this simplifies to is the limit as delta x approaches 0. I still have my delta x squared. And then I have a minus 5 delta x. Remember, all the constants canceled, all over delta x. So notice I have a delta x squared, a minus 5 delta x. I can factor a delta x out. And what I get when I factor is delta x times delta x minus 5. So now I have a delta x on the numerator and a delta x in the denominator, and they can cancel. So I cancel, and I get the limit as delta x approaches 0 of delta x minus 5. Remember, after canceling, we always plug in. So if we let delta x equal 0, then I end up with just negative 5. Now that was the derivative, and remember the derivative is also the slope of the tangent line. So if we have a slope and a point, we can use the point-slope form for the equation of a line. And that is y minus y1 equals m times x minus x1, where m is the slope and x1 comma y1 is the point. So I just plug in. y1 is negative 6. M is negative 5, and x1 is 1. So I get y minus negative 6 equals negative 5 times x minus 1. And just simplify, y minus negative 6 is y plus 6. I can also multiply the negative 5 through, and I get y plus 6 equals negative 5x plus 5. And then subtract 6, and I get my final answer, which is the equation of the tangent line to the function at the point, is y equals negative 5x minus 1. And I'm done with the problem.